All right, so here's the second video that I promised you this morning. This problem that we were not able to solve because I did not read the entire problem. So that is, I know in a number of my videos, like the number one thing to do before you start a problem is to read through the entire problem, which I didn't do. Mass is actually given. And we were on a time crunch, and so I was like really trying to hurry. But if we read through the whole not we, this is not a we thing, this is me. If I had read through the whole problem, this is actually a relatively simple problem to solve. And because I know now that change in momentum was a part of the chapter, we can just use that and we don't have to solve for any sort of intermediate things. So going to be like 5 minutes to solve this problem, if not even less. All right, so we have a car stopped for traffic. When the light turns green, the car accelerates, increasing its speed from 0 to 5.2 meters per second in 0.832 seconds. What are the magnitudes of the linear impulse and the average total force experienced by the 70-kilogram passenger in the car during the time accelerates? Number one should be read through the entire problem before you begin. All right, so we've done number one. Now let's do our next step, which is draw a picture. So number one, draw a picture. We got a car, we'll call it M1, and it is accelerating forward. And we can also say it then has a momentum. Okay, so we've drawn number one. Number two is, what are we given? So we are given M1, 70.0 kilograms. What else are we given? We're given V naught is 0. We're given VF is 5.20 meters per second. We're given delta T equals 0.832 S. Okay, is that everything we're given? Is that everything we're given? Number three, write down what they're asking. They are asking for impulse. Number four, write down the equations we know. So we know this. Newton's second law. Know it, love it. No. Pencil. And I think for this is all that we need. So we're going to do, let's solve. We're going to do I equals delta P. We can write this up here because this is an equation we know. This is usually written as this. Now, writing it out this way is important when you have something that is losing mass. So like say a common problem is like a rocket going into space or it's losing mass. But for us, the mass stays the same. So we can use this. So I equals, oh, this is, so let's say this is A. I equals mass, which is 70.0 kilograms, times VF, which is 5.20 meters per second, minus 0. And if we do the math, we end up with 364 kilograms per meters per second. Okay, so B is asking for the average total force experienced by a 70-kilogram passenger in the car during the time the car accelerates. Okay, we know Newton's second law. So we go F equals mass times acceleration. And acceleration is just delta V over delta T. That could have been an equation that we wrote down, but I sort of don't even think of that as an equation, because what is acceleration? Acceleration is the change in velocity over the change in time. It's sort of like a definition. If it is helpful for you to write that down, write that down. So then we have F equals mass, 70 kilograms, times delta V over delta T, which is 5.20 meters per second over 0.832 seconds. And we end up with 438 newtons. And directionally, we're going to say in the positive x direction, which if we, of course, in our picture, we should have started this way. We'll call that x, and this is forward. So it will be in the positive x direction. Yeah, linear impulse should have been that also, right? It would be kilograms per meters per second. It would also be forward. So it would be in the positive x direction. Right, I hope this is helpful. Watch these videos, look at what I've done here, and if you have any more problems, I will be working on research most of the rest of the day. So send them to me and I can quickly solve them and send you a video. All right, see you soon, Phoebe. Good luck.